Good morning, guys, and welcome to my channel, Mind Your Math. A very interesting topic we are going to learn today, time and how it is related to work. A very basic topic, but this particular topic is the basis of many questions, not just for your class examinations, but also for many competitive examination, including the examination for MBA entrance. You know that when you are learning a particular topic in your grade, there are some basic concepts that has to be understood before you learn that particular chapter. For example, if you are learning linear equations, you should at least know what a variable is, what an algebraic expression is, right? So even for this chapter, which is time and work, you need to have a basic understanding of these two basic concepts. You must have already learned direct and inverse variation and how to apply unitary method in order to solve certain sums. So now I will start with a very simple sum on time and work, and let us see how we can apply these methods. Now when I am saying these methods, you can either choose a unitary method or the direct and inverse variation depending upon your comfort factor. In certain sums which are a bit complicated, you might have to use both these concepts, but in all the other cases, either one of them, either the unitary method or the variation direct and inverse is required to solve the sum. Now what you want to use is entirely left to you. You also can switch between the methods looking at the sum and your comfort factor. Okay, so now let us start with a very simple sum. So you have read the question. It is given that a person called Amit needs 4 days to finish a work, and another person, Sumit, needs 6 days to finish a particular work. So suppose if they are working together, how many days will they take to finish the work? Okay, or the same amount of work. So Amit takes 4 days and Sumit takes 6 days. So when they are working together, naturally the number of days should be lesser than either this or this. Basic logic. So in order to do that, we should know what is the amount of work that is put in by Amit as well as Sumit in one single day. Now, the amount of work that Amit does in one day is 1 by 4. The amount of work that Sumit does in one day is 1 by 6. Now, in a single day, when both of them are working together, what is the amount of work that they do? It is a sum of 1 by 4 and 1 by 6, which will give us a 5 by 12 once we take the LCM, which basically means that out of the entire work that is to be completed, 5 by 12th of the work is completed if both of them are working together. If only Amit was working, 1 by 4th of the work will get completed. Only if Sumit only was working, 1 by 6th will get completed. Now both of them are working means 5 by 12th of the entire work is completed. Now we need to decide how many days do they need to complete the entire work. Since 5 by 12th of the work is completed in a single day, let us take both of them uses X number of days to complete the entire work. So 5 by 12 into the number of days will get me the complete work. So the number of days is given by 12 by 5. Now you cannot write 12 by 5 days. Please convert it into a mixed fraction, which will give us 2 and 2 by 5 days. Okay, I hope this is very clear. We basically converted the work done by individual people into the work done on a single day, then added them and then found out the total number of days that are required. The second sum is almost similar to the first sum, but we need to find a different parameter. It is given that Mohan takes 9 hours to finish a particular work, and Mohan and Sohan takes 4 hours to finish the same work. Now we need to find how much time Sohan takes in order to finish the same amount of work. So I have taken the amount of time that is required by Sohan to be n hours. I told you the way to start this kind of sums is to base it on a unitary method. So if Mohan takes 9 hours to complete a work, the work done by Mohan in 1 hour will be 1 by 9th of the entire work. Mohan and Sohan takes 4 hours means if both of them are working together, the amount of work completed in 1 hour will be 1 by 4. Correct. But what is this 1 by 4 actually? 1 by 4 is the amount of work done by Mohan in 1 hour plus amount of work done by Sohan in 1 hour. Amount of work done by Mohan in 1 hour is 1 by 9. The amount of work done by Sohan in 1 hour will be 1 by n. Now we need to find the parameter and we have got a very simple equation. Now let us see how we can solve this. After solving for n, you can see that n equal to 36 by 5 hours, which I have converted into a mixed fraction, giving us 7 and 1 by 5. I hope all of you are clear with the explanation of the previous sum. Now, we have been talking about the work done by two people individually and as a team. Now, let us add one more person and make it into a sum wherein it involves the work of three people. It is given that A, B and C can finish a work in 8 hours. A alone can do it in 20 hours and B alone can do it in 24 hours. So we need to find how many hours will C take in order to complete the work all by himself. Okay, so now like in the previous question, we have to convert it into the work done by these people in a single hour or in a unitary way. So A, B and C can finish the work in 8 hours. So in 1 hour, A, B and C will be doing 1 by 8th of the whole work. Correct. Now, A can finish the work in 20 hours. What is the work done by A in 1 hour? It is 1 by 20. What is the work done by B in 1 hour? 1 by 24. And that of C is 1 by n. So, in 1 hour, A will do this much of the work, B alone will do this much and C alone will do this much. When all these three are combined together, the work will be 1 by 8th of the whole work completed in 1 hour by A, B and C. So now it is very simple. So 1 by 20 plus 1 by 24 plus 1 by n is 1 by 8. Now we need to find the value of n. Let us solve this equation. After solving the equation, we will get the value of n as 30 hours. We are able to solve 1 by n as 1 by 30. So taking the inverse, n is equal to 30 hours. This sum is slightly more complicated than the previous one. For different people, different combinations of working hours, and we need to find how many hours will A, B, C and D take together in order to finish the work. Now, the basic understanding is the same. Whatever be the number of hours or number of days that are given to you, your first objective will be to convert it into a unitary factor, either 1 hour or 1 day, depending upon the question. In this particular question, A, B and C can finish a work in 15 and 3 by 4 days. So, the first objective is to see how much of work A, B and C can do in a single day. Same logic will apply to this combination, this and this combination. Now, let us find out each of the different values. So, here I have written the work done by all these different combinations of people in a single day. The first one I have converted into a improper fraction and taken the reciprocal of it. So this is what you are getting. So what do we do next? We try to find out the work done by all these people in a single day. So but in this case, an individual person's work is not given. The combination is given to us. No problem with that. When we are adding all this, what are we getting? We are getting the work done by A, B and C in a day, B, C and D in a day, C, D and A in a day and D, A and B in a day, which means we are basically adding A's work thrice, B's work also thrice, similarly C's work and D's work. So this is what we are getting. 3 times their work in a single day is given by 4 by 63 plus 1 by 14 plus 1 by 18 plus 1 by 21. Okay, slightly complicated fractions, but not to worry. So when we are taking the LCM of these denominators in order to add them and make it into a single fraction, what are we getting? We will get 126 as the LCM. Correct? So here I will be getting 8 and here I will be getting 9 Here I will be getting 6 and here I will be getting 7. Correct. Let me add them together. I will be getting 9 plus 8, 17, 17 plus 7, 24, 24 plus 6, 30, 30 by 1, 26, which I am going to reduce into 15 by 63. Okay. But you need to remember that this is thrice the work done by A, B, C and D in a single day. Correct. So, in order to get the exact work done by A, B, C and D in a single day, I need to divide by 3. So, I will be getting 5 by 63. Right. This is the work done by these 4 people in a single day. So, what are the number of days these people will take to finish the work? It will be 63 by 5. Now, since the question is given in mixed fraction, we need to convert 63 by 5 into an improper fraction. So, you will get the final answer as 12 and 3 by 5. A and B finish a certain amount of work in 10 days. Now, A alone can finish 1/4 of the work in 12 days. We need to find the number of days that B will take to finish the entire work. Now, normally in the sums, what do they give you? They give you the number of days that A takes to finish the entire work alone. Correct? In this case, it is given that 1/4 of the work is completed by A in 12 days. So, if 1/4 of the work is completed by A in 12 days, how many days will A take to finish the entire work alone? So, 1/4 of the work is completed in 12 days. Correct. So, to finish the entire work, A will take 12 into 4, 48 days. So now we know how many days A will take to finish the complete work, which is 48 days. So what is the amount of work done by A in one day? It is 1 by 48. Correct. Now what is the amount of work that is done by A and B together in a single day? It is 1 by 10. Okay. Now suppose if B is taking n days to finish the work done by B in one day is 1 by n. Okay. So, we go back to the original basic underlying concept, which is work done by A in one day plus work done by B in one day is the work done by A and B together in one day. Now, the only thing that is pending is to find the value of n. Solving for n, you will get the value of 1 by n as 19 by 240, which will give us the value of n as 12 and 12 by 19. Okay, so now we have a slight variation of the sums that we have done so far. So in the previous sums, we had people working together and one of those people who was involved in the work left after a particular day or a particular number of days, and then we needed to find how much of time the other person took to complete the job by himself. In this case, there are two people A and B whose output is given by A can complete the work in 6 days and B can complete the work in 4 days. A started working and worked for 2 days and then was joined by B. Now we need to find the total time that is taken to complete the entire work. Okay, so if A takes 6 days to complete the work, our first go-to step is what is the work done by A in a single day. So A can do 1 by 6th of the work in a day. B can do 1 by 4th of the work. Fine. A and B can together do 1 by 6 plus 1 by 4 of the entire work in a single day. But what happened here? They are not working together. A started working and worked for 2 days. So the productivity of A is 1 by 6 of the work in a day. For 2 days, it will be 1 by 3 of the entire work. Now, how much of the work is pending? 1/3 of the work is over, 2/3 of the work is pending. So, 2 by 3 of the work is remaining. Correct. Now, after 2 days, what happened? B joined A. When B joined A, their productivity automatically went up to this in a single day. So, 5 by 12 of the work can be done by A and B in a single day. Okay. Suppose they need to work for n number of days to finish the remaining work, and the remaining work is 2/3 of the work. Okay. So now let us write 5 by 12 into a number of days taken by A and B together will give me 2/3 of the work. Now to find the value of n, it is 8 by 5. So A and B has to work together for 8 by 5 days in order to finish the remaining work. But A has already worked for 2 days. So what's the total number of days? It is 8 by 5 plus 2, which is 18 by 5 days. Okay, I hope you are clear with this. A started working together. No, A started working alone and worked for 2 days. So how much of the work is completed? It is 1 by 6 into number of days, which is 1/3 of the work is completed. So how much of remaining work has to be completed by A and B together? 2/3 of the work. When A and B started working, this is the productivity in a single day. They are working for n number of days. So the value of n is 8 by 5. That is the number of days taken by A and B together. We need to find the total number of days. We need to add the initial 2 to 8 by 5 in order to get 18 by 5 days. Now we move on to a different kind of sum in time and work. So basically the approach is the same, but the framing of the question is slightly different. 8 men can do a piece of work in 9 days. How many days will 6 men take to do the same work? Okay, so I will show you 2 approaches in which you can do this sum. I wouldn't say these approaches are, very different, but one is based on the method that we have been following so far. 8 men takes 9 days to finish the work. So work done by one man in a single day. We are making both into a unitary thing. So work done by one man in a single day will be 1 by 72. Okay. Now, how many days will 6 men take to finish the same work will be 6 men can finish 1 by 12th of the work in a single day. So, they will take 12 days to finish the complete work. Now, let us do this sum by using the second approach. 8 men takes 9 days to finish the work. So, how many days will one man take to finish the same amount of work? What you need to understand is that I am not asking you the amount of work done by one man in a single day. I am asking how many days will one man take to finish the same amount of work. Automatically, that has to be much more than what 8 men will take. Correct, because there is only one single person working, so he has to take more number of days. One man will take as many number of days as 8 men, thus giving us 72 days in order to finish the work. Now, when I am employing 6 men, automatically the work will get reduced. So, 72 by 6, 12 days. In the first case, we found out what is the amount of work done by one man in a single day. You got 1 by 72. So, when you are employing 6 more people into it, it is 6 into 76 into 1 by 72, giving us 1 by 12. That is the work completed by 6 men in a single day. So, you will get 12 days as your answer. In the second case, I am asking you, what is the number of days taken by one man to finish the same work? Which means that as many number of days as 8 men has taken, one man will take. Then you apply it for 6 men. I hope you are clear with these 2 approaches. Whichever approach you are comfortable with, you are free to follow. But if you are asking me an opinion, follow the second method. "35 baskets can be woven in 25 days. How many days will it take to weave 55 baskets?" So you obviously know that it has to be more than 25. Correct? Because the number of baskets are more. 35 baskets for 25 days. So how many days will it take to weave one basket? Sums like this, you need to use your logic. 35 baskets take 25 days. One basket has to take much lesser. So it is division. So one basket can be woven in 25 by 35 days. Now it's very simple. 55 baskets can be woven in 25 by 35 into 55. Okay, so now let us cancel the common factors, and here you will get 275 by 7. Convert it into a mixed fraction. Now let us move on to the next type of sum. 12 boys earns rupees 840 working for 7 days. What is the amount or what is the money earned by 15 boys working for 6 days? Now this kind of sums are actually very interesting. Let us see how we can solve it quickly. 12 boys earns 840 in 7 days. Okay. So if 12 boys are working not for 7 days but they are working only for 1 day, how much money will they earn? Will they get more money or less money? It is obviously less money because they are working for lesser number of days. So it is 840 by 7 giving us 120 rupees per day. That is for 12 boys. If there was only one boy who was working, will he get more money or less money? Lesser money. So 10 rupees in 1 day. So one boy working for 1 day will get 10 rupees. So now we have 15 boys. Will 15 boys get more money or less money? More money. So 10 into 15 working for 1 day. Now how many days are mentioned in the question? 6 number of days. More number of days, more money. So 15 boys will get 10 into 15 into 6 working for 6 days. So this is 10 into 90, which is 900 rupees. Clear? So what do you need to keep in mind? If there is a quantity that is to be found, the remaining two quantities over here have to be made into a unitary value. So here I have made the number of boys into one boy and the number of days into a single day. Before I proceed to find how much of money will 15 boys earn for 6 days. Now let us do one more sum which is similar to this. 9 girls takes 3 hours to make 135 garlands. How many girls are needed to make 270 garlands in 1 hour? Okay. So now let us proceed this sum as we did in the previous sum. 9 girls can make 135 garlands in 3 hours. So how many garlands can they make in 1 hour? Will it be more or will it be less? It will be lesser because the time is reduced. So 9 girls can make 135 by 3 garlands in 1 hour. Clear? So now, how many girls are required to make 135 by 3 garlands in 1 hour? 9 girls, correct. How many girls are required to make 1 garland in 1 hour? Will it be more or will it be less? It will definitely be lesser because the number of garlands is reduced substantially. So, 9 divided by 135 by 3 girls are required to make 1 garland in 1 hour. Okay. So, here you will get 9 into 3 by 135. Now, what is the question? How many girls are required to make 270 garlands in 1 hour? So, in order to make 270 garlands, the number of girls will be more or will be lesser? It will definitely be more because the number of garlands is more. So, this into 270. Now, let us find the value. When you divide by 5, you will get 27. Here, when you divide by 5, you will be getting 54. 54 girls are required to make 270 garlands in 1 hour. Now, let us move on to the next type of sum. 12 boys earns rupees 840 working for 7 days. what is the amount or what is the money earned by 15 boys working for 6 days. Now, this kind of sums are actually very interesting. Let us see how we can solve it quickly. 12 boys earns 840 in 7 days. Okay. So, if 12 boys are working not for 7 days but they are working only for 1 day, how much money will they earn? Will they get more money or less money? It is obviously less money because they are working for lesser number of days. So it is 840 by 7 giving us 120 rupees per day. That is for 12 boys. If there was only one boy who was working, will he get more money or less money? Lesser money. So 10 rupees in 1 day. So one boy working for 1 day will get 10 rupees. So now we have 15 boys. Will 15 boys get more money or less money? More money. So 10 into 15 working for 1 day. Now how many days are mentioned in the question? 6 number of days. More number of days, more money. So 15 boys will get 10 into 15 into 6 working for 6 days. So this is 10 into 90, which is 900 rupees. Clear? So what do you need to keep in mind? If there is a quantity that is to be found, the remaining two quantities over here have to be made into a unitary value. So here I have made the number of boys into one boy and the number of days into a single day before I proceed to find how much of money will 15 boys earn for 6 days. Now let us do one more sum which is similar to this. 9 girls takes 3 hours to make 135 garlands. How many girls are needed to make 270 garlands in 1 hour? Okay. So now let us proceed this sum as we did in the previous sum. 9 girls can make 135 garlands in 3 hours. So how many garlands can they make in 1 hour? Will it be more or will it be less? It will be lesser because the time is reduced. So 9 girls can make 135 by 3 garlands in 1 hour. Clear? So now, how many girls are required to make 135 by 3 garlands in 1 hour? 9 girls. Correct. How many girls are required to make 1 garland in 1 hour? Will it be more or will it be less? It will definitely be lesser because the number of garlands is reduced substantially. So, 9 divided by 135 by 3 girls are required to make 1 garland in 1 hour. Okay. So, here you will get 9 into 3 by 135. Now, what is the question? How many girls are required to make 270 garlands in 1 hour? So, in order to make 270 garlands, the number of girls will be more or will be lesser? It will definitely be more because the number of garlands is more. So, this into 270. Now, let us find the value. When you divide by 5, you will get 27. Here, when you divide by 5, you will be getting 54. 54 girls are required to make 270 garlands in 1